Hello, and welcome to this class on the design of monetary policy rules. Nowadays, central banks set the interest rate to achieve their goals. In the Federal Reserve's case, they adjust the federal funds rate. But the Fed faces a trade-off between their goals of stable prices and maximum employment. Remember the Phillips curve. In this session, we will discuss how this trade-off is approached in practice. We will introduce the idea of an output gap and an inflation gap. We will then ask what central banks should do about these gaps. We will examine Milton Friedman's K rule, which says that monetary policy should not respond to economic conditions. And then we will examine the famous Taylor rule that ties interest rates to gaps or fluctuations in inflation and employment. Remember the Federal Reserve's dual mandate: maximum employment and stable prices. Let's first focus on maximum employment and describe how this target can be achieved. Unemployment and GDP are closely connected. This relationship is called Orkun's law. As a result, we often talk about economic growth and unemployment interchangeably. When an economy is fully utilizing its resources, we say that the economy is producing its potential GDP. When the economy is at potential GDP, this implies full or maximum employment. This is just about the best we can hope for. So, to achieve maximum employment, central bankers need to know if the economy is close to potential GDP. What does this look like in the data? In the chart, you can see an estimate of potential real GDP of the US through 2030. A branch of the US government, the Congressional Budget Office, estimates potential GDP. This is a purely theoretical construct. It grows over time due to projected improvements in technology, education, and demographic trends. And here's the actual real GDP. While the two track each other closely, there are notable deviations. This chart shows these deviations. It is calculated as the percent point difference between the actual real GDP and potential GDP. This is called the output gap or the GDP gap. There are times when the output gap is positive. These are boom times when the economy runs hot. Resources are used more than they will be in the long run. Workers may work overtime and extra shifts and so on. Positive gaps are less common and small in magnitude. In contrast, negative output gaps can be large and longer lasting. Let's now layer on the unemployment rate. We see that when the output gap is negative, unemployment is higher than usual. The decade beginning in 2008 is a clear example. What is the key insight here? Using the output gap as input for monetary policy makes a lot of sense when maximum employment is one of your goals. Moving on, the second part of the Federal Reserve's mandate is stable prices. Stable prices mean a low inflation rate. But how low? Academics such as John Taylor have suggested that central banks should use a 2% target. The Federal Reserve seems to agree. Since 2012, the FOMC has announced it judges an annual rate of 2% consumer price inflation to be most consistent over the longer run with the Federal Reserve's statutory mandate. Similarly, the European Central Bank shoots for inflation below but close to 2%. Just with the output gap, we can calculate an inflation gap. This measures how much inflation differs from the central bank's 2% target rate. This graph shows you the annual growth rate of personal consumption expenditure. This is a measure of consumer price inflation. We can see that inflation was above the 2% target in the 1970s and 1980s. On the other hand, from the mid-1990s through 2020, inflation was consistently below 2%. So, how should the central bank respond to fluctuation in unemployment and inflation? Should they respond at all? Nobel Prize-winning economist Milton Friedman was skeptical that central banks could make a difference. Instead, Friedman proposed what is now known as the K rule. The central bank should simply increase the money supply by a constant K% every year, say 3%. Clearly, this rule ignores economic conditions. The central bank has no leeway and just follows the pre-programmed algorithm. Why is this a good rule? Well, if large increases in the money supply cause inflation, then moderate money growth should keep prices stable. Another advantage of this rule is that financial markets and businesses can perfectly anticipate all monetary policy actions and base their decisions on it. The belief is that keeping the money supply under control and predictable would promote economic and financial stability. The other class of monetary policy rules are designed to respond to economic conditions. If business cycles are costly, then smoothing them out might benefit society. The most famous rule is the so-called Taylor rule, which ties interest rate decisions to fluctuations in output and inflation. Let's take a look at the Taylor rule. It was originally proposed by academic John Taylor in the 1990s. To begin, recall that the nominal interest rate is equal to the real interest rate R and inflation pi. Let's assume that inflation is at the target of 2%. Let's also assume that the real interest rate in equilibrium is 0.5%. So, assuming that inflation is sitting at target, the nominal interest rate will be 2.5%. That's what the market will deliver without any intervention by the central bank. However, the central bank can choose a different nominal interest rate if it wants to. In fact, let's assume that the central bank chooses the target interest rate to explicitly account for the inflation gap and output gaps with weights alpha and beta. There's your simple Taylor rule. This says the target interest rate should be whatever the market wants, plus an adjustment for economic conditions. More precisely, it says that the central bank should increase the interest rate when there is a positive inflation gap or a positive output gap. This should cool down the economy. And it says the opposite when there's a negative inflation gap or a negative output gap. This should stimulate the economy. This simple rule captures the elements for decision-making at the Federal Reserve. Both stable prices and maximum employment appear in the formula. Of course, we need to find values for the inflation weight alpha and the output gap weight beta. Taylor's original recommendation was to give equal weight, setting them both to 0.5. Economic researchers have since conducted numerous studies to see what these weights should be. Nowadays, the consensus for the inflation weight alpha is 1.5, while the estimate for the output gap weight beta varies between 0.5 and 1. Using monetary policy to stabilize business cycles has been the norm for many central banks in the modern era. But has this approach been successful? Based on the US experience since the 1980s, you might cautiously conclude yes. Here's inflation, unemployment, and interest rates in the United States since 1980. When the 1990 recession started, the Federal Reserve cut the interest rate. Unemployment rates dropped below the pre-recession level within 4 years, and inflation remained low throughout the 1990s. This pattern repeats itself after the dot-com bubble bursts in early 2000. More generally, the low volatility in the macroeconomic variables since the 1990s has been attributed to central bankers and their interest rate decisions. Let's wrap up. In this session, we covered the design of monetary policy rules. We first described how monetary policy targets could be measured in terms of output and inflation gaps. We then discussed how monetary policy rules can be designed to react to these targets. We saw this in the context of the simple Taylor rule. Finally, we saw how interventions by the Federal Reserve seems to have succeeded in the 1980s and the early 2000s.